started, I actually stumbled into the satellite projects, and one of my first missions here was to figure out why the ground station, it's a satellite dish. So it had strangled itself uh, because there was a mistake in programming that it started to follow the satellite dish, but it never stopped moving. So it would turn over and over and over until the cables were strangled, and then it detached itself. So, but then we had to debug the code to have like limits to the degrees that you can rotate the dish. Yeah. Okay. So let's see that we have all the tech here. So you're in second. Um, my talk is about toppling AI. It's not a very common term, so I have to properly explain what it is. But this is sort of like a lighter thing. It's probably nothing new to many of you, but then again, I try to be very technical, so it's very hard for you. Uh, so, mm, um, so me here, my name is Ville Rantanen. Some background: I have a PhD computer vision, AI of that time. Um, and Here in Reaktor, I have been working with optics, electronics, building infrastructure for computation. I've done a bunch of different backends for many projects, ML, and then suddenly it was called AI. And shell life, yes, everything happens in shell, no graphical user interfaces anywhere. And yeah, 8 years so far here at Reaktor Innovations. Yeah, let's see. So what do I mean by bottling AI? Um, so here I'm interested in running language models. They might not always be large language models. They could be small language models. But the point is to bottle them up. So no connection anywhere, being somewhere without internet. And these are the main questions. So why would I do this? Which AIs or frameworks I would be using? Then how would I be using them? And then why should I not use these things at all? Um, yeah, and here's the quote that I found funny earlier. That what does the GPT in chat even stand for? And it's computer. Uh, because it's all someone else's computer, right? Uh, so so why am I doing this kind of talk here? Uh, I feel that sometimes hype about AI currently, especially, is the thing that it lives somewhere else in the cloud, and you connect to it and you can chat it on a web page or whatever, and then some magical things happen somewhere else, and it's even a person or something that discusses back, chats to me, and while the reality is, of course, that it's just someone else's computer and it's someone else's software, right? So there's no magic there, and AI is something else than just an API and running somewhere else. And it's kind of like the same argument I would have used back in the day when serverless web technologies arrived, meaning that it's just someone else's computer. Again, so instead of running your own server, you use someone else's server. So that's serverless. And I like to do stuff from scratch at least once so that I learn what is the valuable thing. Why would I buy or use someone else's technology or software if I understand what were the difficult parts in building this? So then I can sort of estimate the price. That's what am I ready to pay for this kind of service? Well, then there are like real reasons, in a sense, that there are many cases where something like this is useful, AI tools, where you simply don't have internet, like let's say space or somewhere else. Uh, Another thing that's happened a while ago when I wrote this presentation was that Cloudflare or AWS East is down. So so then stuff breaks and everything breaks. But if you can have your own systems running that are independent of cloud, you're resilient. Then there's the tinfoil factor. I love this. So you don't want to give your precious secrets to the big companies, big tech, right? So could be one reason. So the use case is, where would I use a bottle up AI? Nowadays, the easy example, everyone does code completion and code generators, coding helpers. And there are cases when you work with a company whose policy strictly says that no, our code base does not go to the cloud, and that's it. So, and you have to do something about it if you still want to use them, the tools. Yeah, I might be writing something, a letter that which contents I don't want to reveal to anyone. So, so then maybe I want to use a tool to fix the image there. Um, any kind of thing. There are so many, of course, everyone knows there are so many AI use cases. And I think you can all come up reasons why sometimes log file scanning or something should not be published to the internet, but instead kept really private. Okay, so then about practical technologies. There may be many more frameworks that run AI models locally. I've used these two, and they are nice examples in the sense that at least, eh, well, in the summer and this fall, early fall, they used to be really different. I think there's some things happening in the development there right now. Development, I've been following VLLM development, and they have like a batch update of 500 lines every day into the code base. So the development is quite heavy. And for simplicity, I'll be using the same model. So here it's going to be the Quen 3 coder with 30 billion parameters for both examples. Okay, so what is Olama? Not very much in the details, but there's a website and you can check out what it is. But the thing, if I want to use it on my own machine, uh, I have to download a 2 GB binary from their website, and it has the compiled executable, and then I run it and it works. There's also a 3 GB Docker image that you can download and get stuff working. The I'll be showing this later, but there is a folder where it stores the intelligence or the model. So the big binary blob that is actually the model weights file, and they have their own content developer network. So they have a small selection of models that you can download and that are compatible with this framework, and you have to choose from them. And this Olama is really easy to use, and they're like nice automation. It can run on a GPU-less computer pretty nicely. Just for fun, yesterday I was running it in a server with 64 CPUs, and it actually spreads nicely. So if you have huge number of CPUs but no GPU, it still works pretty much. And it even has its own chat client, command line interface, of course. Annoying things, it has a REST API, but it's completely proprietary. So there is no standard, and they have their own version. And it used to be slow. I mean, really compared to this PLM last September, even in October. But now that I installed it lately, it's suddenly become quite much faster. So this argument doesn't necessarily hold anymore. Then briefly about this VLLM, uh, uh, it's just another framework, but something different goes on there. If you try to install, it's a Python package, this VLLM, and if you install it, it's gonna install everything in NVIDIA space. So 10 gigabytes of libraries will be downloaded. Or you can get the Docker image, which is 20 gigabytes. So bit like, I mean, it's not a lot of data, right? But it's not big data, but it's still larger than Olam. And yet again, there's a folder where it downloads the models, and they are using Hugging Face. So basically, you can use any model that is available in Hugging Face, and that space is of course huge. There's like absolutely everything you can find at Hugging Face, but it's a lot harder to use. Just to make it work, it doesn't work. Just typing the executable. No, there's at least, I think, 5 parameters or switches you have to set in order to get anything working. But the nice thing is it is fast, and there's a standard API. It's an OpenAI standard REST API. Okay, so here we are going to use, there's a demo, and it's going to be a live demo, and there are so many breaking points here that I'm not even going to mention all of them. You love a challenge. I love a challenge. Yeah. So this is using a classic server client based architecture, in the sense that I'm running a server, because of the foils and the thin foil factor is going to be running in EU. Uh, uh, there is a GPU on that machine, and I'm going to download, or actually I've done part of this already, so we don't have to wait. So downloading Olama and the models that I wanted to use, and I'm going to show you the scripts as well. That's the technical part, but you have to then understand what's going on there. Of course, in the sense of uh, later thing that this talk is supposed to be bottling the AI up and then using it somewhere else, but I cannot really show that somewhere else place here. But I have to simulate that my cloud-based computing computer is that place that cannot connect to internet. We'll just have to believe it as magic words. But of course, just to download the models, I don't really need this GPU instance. But to demonstrate to you that it actually works, for that I do need it. Yeah, I'm gonna show it from the command line, but that also using a continued plugin that works on VS Codium, because code generation is so much fun. Okay, demo time. Here, let's see. What did I have to show you? Okay, so if I would want to bottle up Olama, this is what I would do, and I have already done. So choose the model I want to use. Go to olama.com and select from the list from all of the available.
Sorry, is it possible to zoom?
Yes, it is. Now I have to scroll up a little bit. Better?
Okay. I can go bigger.
All right. So first, select the model. Here, it's the Gwen coder. For Olama, I need to start the server because that's the server and the client all in one executable, and then command it to pull the model, right? But I know that it's going to save it in this folder. And this one, I can package it and put it in the tar file and then ship it somewhere else and extract into that same path in another computer, right? Of course, I need the binary as well. This URL, this package contains this binary. So of course, I'm going to need that as well. If I would want to use Docker instead, I could pull it and then save it and ship it to my other hidden computer somewhere, and then use it there. Yeah. Okay. Just an example that yes, here in my computer, these are the files that I downloaded. Okay. I need to make the file a little smaller. Okay. If I want to then run the server itself, this is basically what I do. I have been experimenting with 2 different GPUs, so the L40S and something else. And this one is large enough to host 2 of these Qwen models at the same time. So I can do parallelization. I mentioned earlier that Olama is bad at parallelization. It's slow. So if I run 2 models, I can use another tool that's a round robin, that it sends the queries one by one to each. So then I can have this superficial parallelization by running 2 different processes. Okay, so let's run this tunnel. And I did not mention that my security here, because I'm using the REST API, which is HTTP, and it doesn't have any encryption, then it's using SSH tunnels to encrypt my data, because I need to be careful about my data. Okay, so how would I use it? I can now interact the coder. So if I run Olama, run, and the model name, then I end up in a shell, and let's ask it something. Why did the Python cross the road? Okay, let's see. It wanted to avoid the return statement. Okay. All right. AI is not that good in making jokes. Okay, another demo. I have a script here in this folder called launcher, and then I can use it like this to make any kind of command line tools. It's actually pretty easy to use. Yeah.
So is this model based on OpenAI APIs or is this?
This Olama is using their own REST API, and here I'm using the same binary for the server and the client, so they can talk more efficiently as well.
So it's been built from scratch.
Yeah, the framework, yes, but they use someone else's model, and here the model is this Quen. It's a Chinese made model that you can download for free, right? Yeah. So here, for instance, just making any kind of command line tool to analyze what is this code, and it tells me that this is a Python script and it's designed to interact with Scaleway cloud platform, and it tells me nicely what can you do with this, so you can launch new virtual machines. And this is the script that I use to provision my Scaleway instance. So it tells that nicely. Okay. Let's see. Then the what I have to of course use, but there's an editor, and you can use the same AI for code generation. So let's just see that it works. It's gonna load the model another time. Uh, yeah, in the log you see that there's something going on, and here's the answer. Okay, now let's do a code review on ML, but please be gentle. No mistakes. Yeah. So I have a script here that I built really quickly some time ago. It fetches our staff, scientists, data scientists, and it takes the projects that people have been working on, and then rotates the list so that it's not user based but project based list of who have been doing different kind of projects. So, but this is really hastily done, and so there should be a lot of errors here. So some minor issues commented out, and there should be, yeah, there's a call to an store to SQLite, and this is an empty function, and it found it nicely. And then the other classic example is then the code generation. I don't know, finish it, mistakes, no mistakes. Yeah. So, and this is a nice example in this. I know we don't have the time to go through all of the code, but there are two functions that declare dictionaries, and they have keys. And this one here, it defines keys, but then there are later like additional keys that are only added if something. So in a way, complex code. Then there's another function that assigns a different kind of dictionary, and it actually could read from the code that which dictionary is being used here, and it's creating the same names for the columns. Yes, please.
Would you be able to do this without any GPU?
Yes, you need just the decent amount of RAM. So let's say 30 gigabytes of RAM is enough to run this model. 40 gigabytes maybe, but it's super, super slow. Smaller models work faster. So with smaller models, like let's say 7 billion parameters, this is 30. So 7 billion parameters, you could use a modern laptop like this, and you get like 3 words a second, maybe, or something like this. So it's borderline usable for some cases.
I tried 13 billion, so it's usable, still usable without GPU. Like on the edge.
Yeah, it depends a lot on the GPU. And if you have an Apple computer with M1, that's something that it can utilize much better, of course. All right. Okay. So this is how I would use it, for instance. Uh, so I showed you everything with Olam, and it's actually pretty fast. Like if I demoed this a month ago, the output would be really slow compared to that. So they actually developed it better somehow. I don't know what's happened there. Yeah, but then what would I do in actuality? So all of this was now done at the computer that's in the internet. But of course, the main point of this uh, is that I would now ship those binaries to a no internet environment. Perhaps there I have a GPU server that I named computer, and the developer using that computer. And here in the internet, I would be using those same commands I showed you earlier to store everything in binary, and then in this restricted computer, load them up, extract, and then use the same kind of tools there. So this is quite how easy it is. Then I have to say, because I've shown this in a few internal meetings, and now the discussion always steers into should you be using AI or not? Uh, but for that reason, and why this demo exists in the first place, is that the main point is that it's possible to take quite good models. You saw that it works, even to some good extent, and it's possible to take them, download them, and run them in a restricted environment. And uh, if you would be running, if you just hate OpenAI for some reason and you want to use all of your money for Scaleway and running these models, it's going to be expensive. I mean, um, the instance I'm running now is €1.5 per hour. So it's probably bigger than the license for any commercial uh, AI provider. But of course, that's the reason is that if you have multiple users, it's gonna be cheaper, right? Because most of the time the GPU is idle if you only use it alone. So there's a breakpoint somewhere at how many users you can use in a single GPU machine and how many people are actually using it and how much it costs. Okay, so um, this is kind of the side end note that it's not about is it okay to use AI or not, but rather that it's possible to take these tools and hide them somewhere in the depths of no internet. Thanks you. And as you can see, for future events like this, there is really no kind of pressure on how good quality or presentation. Yeah, do you have more questions?
So this framework, like, do they have like sort of like a light version that can run like on low-end devices, for example?
Yeah, I mean, I think the smallest versions you can download for different model is like 0.7 billion parameters. So that's like very small. And I think it's like 700 megabytes is the actual weights file. So that's very small. But once you start using it, you sort of notice it's like 5-year-old age kind of level. And you can see there's a lot of mistakes. So at some point you have to have a larger model to make it, something really useful. But of course you could teach it something uh, an easier task.
So I mean, like, if you would like pick specific domain,
Yeah.
let's say for example, grammar spelling, for example,
Yeah.
for English only.
Yeah. Yeah. And other things that for let's say command line completion, it's a very small subset of things that can work in a command line. So for a smaller model would work for that. Or let's say uh, log file scanning. That do you have something very specific? It's almost like a grep, right? Uh, but but I mean a little bit more flexible than grep. That there's a pattern of something that could be squeezed into such a small model. Yeah, but good question. Yeah, that was first.
How was your learning experience with E11? Because I used Olama, and it felt really like plug and play.
Yeah.
While I never, it's actually the first time I hear about E11, so I'm not curious to go.
Yeah. I started playing around with that mainly because of how fast it is, and it can use shared memory for the model and multiple queries, and it's super fast. You can have like I did like a batch testing kind of thing where I tried to feed multiple queries or huge data sets and ask questions about some data, and I think it was like 12 times faster than Olama, and with the same kind of RAM requirements. But yeah, there's a ton of switches, and you have to immediately start to use like quantification parameters so that it takes less memory. Um, and even in my case, it's actually in this comparison, the same model used double the amount of RAM for VLLM compared to Olama. So in Olama, I could run 2 servers and then do if my parallelization trick, and then use only one VLLM server in the same RAM space. But even still, that was the 12 times faster. So in reality, it's like 24 times faster, but half memory. Yeah. So yeah, it was, you needed to, try out things a little bit more, but in the end, it was not that hard to make work. Those.
You mentioned that like VLM and Olama like are so many gigabytes. I think it was 2 or 3 hours, something like that. But those don't include the models, right?
No.
So is there an easy answer? Like, what is that? Why is it so big already?
I think one part, the binary. So this is compiled code, and Olama does come with few libraries who does something, but there are also compiled libraries that are there, and I think it assumes that you have the rest installed. Whereas in VLM, it downloads basically everything that starts with NVIDIA that you have in PB index. So there's a lot more, and also there is the CUDA developer libraries are in the Docker image, so it's huge just because of the NVIDIA side of things. That, yeah.
Yeah, one more question.
So this is not like pushing toward direction is AI is growing up.
Yeah, don't worry.
Yeah, this obviously you have a lot of expertise in this domain. So using based on this open source, etc. Have you built anything that you can look like here, like a really like, I don't know, help for your productivity or some specific use case, etc. Not relying on the like a subscription driven like a model like.
Yeah. Yes. I can reveal that I do work a lot in no internet environments. So one of the things is that Googling can be hard. And even if you can go Google and then to transfer the result of the Google to the no internet site can be equally painful sometimes. So either you just remember everything you read and then you go to the place without internet and then you type the things you remember, or something else. Um, but yeah, there are many cases where a decent AI like this actually can work as a replacement Google, because it does know a lot of things, sometimes wrong, but especially when it's a thing that I know how it's done. How do you set up the arg parse get options for my Python script? It's at least 4 or 5 long lines of stuff to get it properly done, and I can ask it from the AI, and it gives it correct. So in those cases when you know the answer, but you don't want to think, and you just get it in easier that way, and you can spot the errors. That's one of the things, that when you have a small model, it's gonna make errors, and so you have to know that where the errors are, but it's usually less work than coming up with the whole thing from scratch, right? So it's a template machine here. Yeah.
See, you were talking about no internet environments and run like reasonably reasonable model.
Yeah.
You need pretty serious hardware, for example,
Yes.
for 30 billions
Yes.
parameters. I think GPU is unavoidable, and having a GPU installed in some, I don't know, satellite or some not internet connected hardware sounds a little bit dumb. And my question is, are you aware of any specific hardware that can accelerate inference besides GPU, but something more like special purpose or more energy efficient?
Yeah, there's a lot of current work in this, and then there are products being shipped. every week. That's no, I can't remember. I would have to ask the AI, but yeah, I just recently saw a news article about one product launch that was similar, and there have been a lot of these before. Let's say 10 years ago, 8 years ago, there were these compute sticks that you could use a Raspberry Pi and insert a compute stick on it.
Google
Yeah.
or something
Yeah.
like that.
Exactly.
But it did some simple things like that.
Yeah, yeah. And here the problem is mainly that these modern models, even if it's like a reasonable 30 billion parameters, it's 30 gigabytes of data. So these kind of older solutions, memory sticks or compute sticks, and they don't have enough memory for that. So currently there aren't there. The GPUs that we use most of the time are too generalized, and I'm sure there's a rush to build something that runs reasonably big models in a bigger memory or bigger bar, and there is a race for it. But I don't know like a good product that's already in the market.
I know Cerebrus is one company that's at least promised to ship something. I don't know where they are in the.
But sometimes it's just a necessity. So in those cases, it feels dumb, but it just might be the only way to do it.
You can always buy a 10,000 euro Mac Studio with shitload of RAM and split that to the GPU part. And,
Yeah.
and
I mean, I was using this L40, and it's only about 10,000.
Yeah, if you buy two of those Mac Studios, you can run pretty nice models.
Yeah.
The fear. Apple charges so much for.
It sounds fun, but this is actually the most realistic nowadays. Maybe it's not necessary to buy expensive Mac Studio, but even simple Mac already have this.
Yeah.
I don't know what
M1s,
they have, but it accelerates
Yeah.
inference.
there are different problems with running Macs in no internet environments.
Yeah.
Yeah.
I do that as a living.
But
I
in the
work
interest
in
of
cyber
time,
security.
we can continue
We can
discussions
discuss
at the
later.
break. But
Thank you.
thank you.
Excellent.